Now let's talk about a geometric figure called the polygon. The term polygon is actually composed of two words poly and gon, which means many and angles respectively. So expect that in this geometric figure, we will be encountering many angles. Now to define a polygon geometrically, it is a two-dimensional geometrically closed figure formed by at least three line segments connected end to end. An endpoint must only be shared by exactly two line segments. I underline the word two-dimensional because I want to emphasize that this figure must be a plane figure, such that there are only two dimensions, the length and the width. It must not have the third dimension, which is the thickness or the height. It is a closed figure because the line segments must be connected to one another, but these line segments, which are always straight lines, should be connected end to end. So in this set of geometric figures, we can actually identify 5 polygons. And which are those? Figure F is a polygon. Same with figure A, figure I, figure T, and figure H. R is not a polygon because it is a cylinder. It is a solid figure, and other than that, you see curved lines. G is a cube, which is a solid figure. It will have thickness, therefore it is not a polygon. L also has curved lines, so it is not a polygon. Y is not a closed figure, so it is not a polygon too. Figure B is not a polygon even if it is a closed figure, because if you look at the line segments, they did not intersect end to end but rather at the middle of those line segments. And lastly, D is not a polygon, which is a circle because of the curved lines. It has no sides. So the polygons in these figures are figure F, A, I, T, and H. Now, considering this geometric figure, we can say that it is a polygon because it satisfies the three conditions. 1, it is a plane figure. 2, it is a closed figure. And 3, we see line segments. Now, in this polygon, there are actually 6 corners, as emphasized by those big dots. But in geometry, we will call them as vertex. There are 6 vertices. How do we name the vertices? We have vertex A, vertex B, C, vertex D, E, and F. And using these vertices, we can also name the polygon. By writing the vertices consecutively, the name of the polygon is ABCDEF. You can also name it as BCDEFA, or you can have AFEDCB, for as long as the vertices are consecutively written. You are not allowed to name it as ACEDBF because those vertices are not consecutive. Now, there's another part of a polygon which is called the side, and this side are the line segments. There are also 6 sides in the given figure. We have side AB. We have the symbol for segment on top of AB because sides are line segments. We also have side BC, line segment CD, side DE, side EF, and also side FA. Another part of a polygon that you can see is called the interior angle. Obviously, it is an angle inside the polygon. And there are also 6 interior angles. What are those? We have angle A, angle B, angle C, angle D, angle E, and angle F. Now expect that in a polygon, if there are 6 vertices, there will also be 6 sides and 6 interior angles. But another part of a polygon which you cannot easily see in a given figure is what you call the diagonal. How do we draw the diagonal? To draw a diagonal, we connect 2 non-consecutive vertices. So for example, from point F, we connect points F and B because F and B are non-consecutive. The consecutive vertices of F are A and E. So its non-consecutive are points B, C, and D. So segment FB is a diagonal. We can also draw other diagonals from point F. So the first diagonal is diagonal FB. We can also have diagonal FC because C is non-consecutive with F. We can also have diagonal FD because D is non-consecutive with F. Take note, when we talk about diagonals, these are line segments that connect non-consecutive vertices. But of course, we can also draw other diagonals from other vertices. Now, those are the 4 basic parts of a polygon, namely the vertex. It is the corner of a polygon. It is the intersection of the line segments or the sides of the polygon. We also have the side. It is the line segment that connects the consecutive vertices. And different from a diagonal, it is another line segment but that connects two non-consecutive vertices. And of course, the fourth one is the interior angle. It is the angle in the interior of the polygon formed by two consecutive sides. Now, if we consider this polygon, this can be named as ABCDE, or you can have other names for as long as the vertices are written consecutively. We can also have here another polygon named as FGHIJ. Looking at the two polygons, they look differently, but in fact, there are a lot of similarities. For example, they have the same number of vertices, they have the same number of sides, and of course, they have the same number of interior angles. Now, let's consider their diagonals and let's see if they also are similar with respect to the diagonals. If you draw the diagonal of polygon ABCDE from vertex A, we will have diagonal AD and also diagonal AC. From vertex B, we will have diagonal BE and diagonal BD. From vertex C, we have already drawn diagonal CA, so no need to repeat that. We will draw another diagonal CE. From vertex D and from vertex E, all diagonals are already drawn. So all in all, there are 5 diagonals drawn in that polygon. Let's consider polygon FGHIJ. From vertex F, we can have diagonal FI and of course diagonal FH. From vertex G, we will have diagonal GJ and diagonal GI. And from vertex H, we already have diagonal HF, so let's have diagonal HJ. All in all, there are also 5 diagonals. So there are also the same number of diagonals. But looking at those figures, there is a very prominent difference between the two figures. And what is that? That is with respect to the location of the diagonals. On the first polygon, all diagonals are in the interior of the polygon. While on the second one, some of the diagonals are in the exterior of the polygon, specifically diagonal FH. If that's the case, then the first polygon is called a convex polygon. Then the second polygon is called a non-convex polygon or a concave polygon. So that we define a convex polygon as a polygon wherein all of its diagonals are found in the interior of the polygon. And a non-convex or a concave polygon is a kind of polygon wherein some of its diagonals are found in the exterior of the polygon. We can also classify polygons according to the number of sides or the number of interior angles that they have. If there are 3 sides or 3 interior angles, we call it as a triangle. If there are 4 sides, then that's called a quadrilateral. The first quadrilateral is a convex quadrilateral while the other one is a concave quadrilateral. If there are 5 sides, we call it as the pentagon. If the polygon has 6 sides or 6 interior angles, let's call it as a hexagon. If there are 7 sides, then it is called a heptagon. If there are 8 sides, it is named as an octagon. And having 9 sides, we will have there a nonagon. And if there are 10 sides, we call it decagon. If the polygon has 11 sides, we can call it as an undecagon. And if there are 12 sides, we name it as a dodecagon. But having more than 12 sides, for example, there are 13 or more, let's just call it as a 13gon, a 15gon, whatever number of sides there are. So if there are n sides, let's just call it generally as an n-gon. Now with that, let's try to answer the following questions. Number 1, is this a polygon? Yes, because it satisfies the 3 conditions. It is a plane figure, it is a closed figure, and all you see are line segments. Number 2, is this convex or concave? That's a concave polygon because when you draw all the diagonals, some of the diagonals will be located outside the polygon. Number 3, in the given polygon, are segment PQ and segment RS consecutive sides? Nope, because if you look at segment PQ and segment RS, you skipped a line segment or a side which is side QR, so definitely those 2 sides are not consecutive. Number 4, in the given polygon, is segment QS a diagonal? Yes, because Q and S are non-consecutive. So when you connect two non-consecutive vertices, you are forming a diagonal. Number 5. In the given polygon, is segment UP a diagonal? No, because P and U are consecutive vertices, and when you connect the consecutive vertices, you are not forming a diagonal but rather a side. Number 6. What is the name of the polygon? We can name it as PQRSTU. We just mention or list down the vertices consecutively. Number 7. What is the classification of the polygon according to the number of sides? Since there are 6 sides, we call it a hexagon. Number 8. How many diagonals can be drawn from R? There are 3 diagonals. Those are diagonal RP, diagonal RU, and diagonal RT. Number 9. How do you call a polygon with 8 sides? It's an octagon. And number 10. How many interior angles are there in a dodecagon? There are 12 interior angles.